In example 10, we are told to solve the graph of, or rather, solve 4 cos theta minus 30 is equals to 8 root 2 sine theta within the range of theta between 0 and 360 to 1 decimal place. And of course, basically this is coming from 4 cosine theta minus 30. This part of the graph, we know it to be, or it's going to be 4 cosine theta cosine 30 plus 4 sine theta sine 30 degrees. This is obviously coming from, the cosine of a minus b is equals to cos a cos b plus sine a sine b. That is true. So in this case, because we don't know the value of theta, that's what we are looking for, we need to know what is cos 30 and we need to know what is sine 30. So in case you have forgotten what is cos 30 and sine 30 accurately, this is an equilateral triangle. This is 2, that's 1 because it's bisected. This is 1 and this is root 3. So this is 30 degrees. So you can see the cosine of 30 degrees is adjacent of hypotenuse, which is root 3 over 2, and the sine of 30 opposite of hypotenuse, which is a half. So basically what you're going to have, we are going to have this equation is reduced to 4 cos theta multiplied by cos 30, which is root 3 over 2, plus 4 sine theta multiplied by sine 30, which is a half, is equals to 8 root 2 sine theta. All right, if you divide by 2 both sides by this 2 cancels 4 to give us a 2. It's going to be 2 cos theta root 2 plus 2 sine theta is equals to 8 root 2 sine theta. Fine. What is, of course, this is root 3, not root 2. This is root 2, root 3, not root 2. We must make that correction. So, in a nutshell, we're going to have 2 root 3, the cosine of theta, plus 2, or rather we can even directly say is equals to 8 root 2 sine theta minus 2 sine theta. We are expected to give or to get or to find the value of theta. And there is no way we will find the value of theta when we have cos theta and sine theta in the same statement. So we must look for a way to express one in terms of the other and to express both of them in what we know. Basically what we know is that tan theta is sine theta over the cosine theta. That is a very fundamental trigonometric identity. And at that point, we can already see that this can be simplified to be 2 root 3 cosine theta equals to 8 root 2 minus 2 into bracket sine theta, because both of them have sine theta and it can actually be collected outside. That means what? We can easily now divide both sides by sine theta, and this one we are going to have by cos theta, so that we can have tan theta. And we are already seeing if sine theta over cosine theta, right, can be written, then we must clear this. We must divide both sides by 8 root 2 minus 2 cosine of theta. And again, 8 root 2 minus 2 cosine of theta. so that the cos theta cancel out, and this and that cancel out. So eventually we are going to have something to do with the tangent of theta is given by 2 root 3 all over 8 root 2 minus 2. If you use your calculator, you will find that this is 0.3719, just using the calculator, which is 0.3719. And according to that, there is an angle whose tangent is 0.3719. And of course, if you talk about shift tan answer, you get around 20.4 degrees. So theta happens to be 20.4 degrees. But remember, according to all science teachers complaining, theta can be 20.4 because 20.4 degrees, because in the first quadrant all trigonometric ratios are positive, or in the third quadrant, which is 20.4 degrees, and you can see in the third quadrant we are going to talk about 180 plus 20.4, which is 200.4. So therefore theta is going to assume the value of 20.4, or theta is 180 because of that that value, which is pi, or rather 180 degrees, plus 20.4 degrees, which is 200.4 degrees. So yes, we have been able to acquire the value of theta within the range of 0 and 360. Please note that we are still following using the relationship that we learned in the trigonometric ratios, and example 10 is just a proof of how vast we can employ our knowledge, or we can apply our knowledge in solving trigonometric questions. All right?